Hi, I'm Ling-Yen from Bloomberg, and our paper is a practical two-step approach to assist enterprise question answering live chat. This work is in collaboration with my colleague Tarec from Bloomberg. Let's get into the problem we are trying to solve. The problem is in the enterprise customer service domain. A customer raises a question via live chat, and the representative is trying to answer the question. We want to assist the representative so they can better answer customer questions. This is a multi-turn question answering live chat, and the questions from the enterprise customer service are diverse and across several knowledge domains and typically have long form answers. We propose a new approach based on community question answering. A community question answering task is defined as given a new question and a large collection of question common threads, rank the comments that are most useful for answering a new question. Example websites are Quora, Stack Overflow, or Zhihu. So the CQA task has three subtasks. First is question common similarity, referring to in this question common thread, you try to rank the comments below based on the similarity. How similar are they to the original question? More similar, they are ranked higher. Second subtask is question similarity, referring to the text trying to find previously asked similar question similarity. And the third subtask is question external common similarity, which is the ultimate goal of the CQA task. Because if you can do the question similarity really well, and then you use the question common similarity to find the most similar common as a answer to this question, and to see if that common can use it as an answer to the new question asked. So from there, now, if you swap out the common from a question common thread with utterance from the live chat, then you can view a live chat, question answering live chat as a question common thread, like the community question answering website. So then the CQA subtask becomes the question common similarity subtask becomes question within chat utterance similarity, trying to rank the utterance respects to the original question. And the question similarity subtask remains the same. So this leads to our two-step approach, question similarity, where we use a more robust setup for live chat, and answer utterance extraction, which is a new subtask. In the next, I'm going to explain both. So the question similarity, the QQS algorithm, starts with a customer question. This is the first utterance from the customer. We first send to a salutation detector to filter out those questions with just hi or hello. We have about 10% of those, and if it's a salutation, then this QQS algorithm just returns, suggests nothing. And if it's indeed not a salutation, then we send to a search engine to obtain the top 10 search results. Because our backend is Solr, it's a keyword base, so it depends on what keywords are matched. It could be very similar or not similar at all. So we employ a similarity model. Its job is trying to give the search result a similarity score. So if we pair up the customer question with top 10 search result, you get 10 question pairs. And the similarity model will give 10 similarity scores. Its purpose is trying to filter out those low scoring ones and pick those very highly similar historical questions and return. A similarity model's job is taking a pair of texts and output a similarity score. We investigate unsupervised and supervised method. For an unsupervised method, you can use word2vec to represent each text as a vector and calculate cosine distance as a similarity score. For the supervised method, we fine-tune a BERT-based model to be able to classify a question-question pair to be similar or not. That's how the similarity model fits in the QQS algorithm. Next, I'm going to talk about the AUE subtask. Answer utterance extraction essentially is trying to locate where the answers are in a live chat. We investigate unsupervised and supervised method. The first unsupervised method is the CQA-inspired method, question within chat utterance similarity. It's trying to find the most similar utterance with respect to the question. And the second method, you can also view this whole live chat as a document. And for extractive summarization, you are trying to select the most important utterances, and those are assumed answers. And for the supervised method, is a classification method trying to classify each utterance as answer or not. So we first conduct a utterance annotation task to label each utterance as with its dialogue act, question and answer related. For example, this utterance is a question, it starts and complete itself, and if the utterance are part of the answer, we'll label as answer, and the rest label as other. If we have this kind of data, we can directly test our unsupervised methods. So for question within chat utterance similarity, we can use the same word2vec cosine we used before to represent the question as a vector, and all the utterance from rep as vectors. And you can compute cosine distance to see which utterance are most similar to the original question. And those are the assumed answers. And for extractive summarization, you can use something like latent semantic analysis, trying to treat this whole utterance text as a document and pick the most semantically important utterance from rep, and those are assumed answers. For the supervised method, we have a BERT-based model. We first do unsupervised domain adaptive fine-tuning to bring the BERT pre-trained model to our domain. And then we do test-specific fine-tuning so the model can classify a candidate utterance as answer or not. For both fine-tuning procedures, we extend the BERT vocabulary and the procedure to account for 3 dialogue tokens. So the client and the rep tokens represent the speaker information, and the enter token represent when user click the enter or return key. So those are trying to account for the structure of a live chat where it's a conversation between 2 speakers turn by turn. So we talk about our QQS and AUE subtext. Now let's review the performance. So for the QQS subtext, we conduct a search result annotation task, basically trying to label the 10 search results and see if they are similar to the original question or not. So for the Solr baseline, basically all 10 search results are considered predicted similar. And for the similarity model on top of the search results, we use a threshold score 0.5. If greater than that, then it's a predicted similar. And with the prediction we compare with the true label from annotators, we can calculate F1 score. As you can see, the BERT QQS similarity model improve upon the Solr baseline for about 9 points F1 score, indicating it can select highly similar historical questions. For the AUE subtext, we use utterance annotation we talked about, and the similarity model performing at 64% F1 score. And the extractive summarization, LSA-based method, is performing worse. And for the supervised method, we are achieving a high F1 score, 87%. And the domain adaptive fine-tuning accounts for more than 4 points F1 score. Our application is deployed to production, and see the left-hand side chart. First, if a new question is coming in, then our question component will select up to 2 similar historical chats and display to the representatives. And if the representative clicks into any suggested chat, our AUE component will locate where the answers are and highlight those answer orders for the rep in the whole chat. So with that, we track a few production statistics. We have about 40,000 questions per week, and about half of them, the QQS will have a suggestion. This is called coverage or triggering rate. Is the percentage of question triggered at least one match historical chat from QQS. This is to measure the overall impact of the system. And the click rate of triggers is the percentage of a trigger question that rep click into any suggestions. This is trying to measure the performance of the QQS algorithm. So more than 1 in 3 the suggestions are used. And the paste rate is trying to track the percentage of click questions that rep copy and paste the suggestion when answering a customer's question. This is trying to measure the end-to-end performance of the QQS and AUE. However, it's a lower bound for the actual usage, since sometimes a representative can read the suggestion but type into their response in order to customize it for the customer. Okay, let me quickly conclude here. We present a new approach inspired by community question answering to assist enterprise question answering live chat. We share our evaluation results and backed by production user engagement data to provide an external validation. Thank you for your attention.